So let's look at perpendicular bisectors. Perpendicular bisectors. That's a couple of pretty big words there. Perpendicular, as you know, or hopefully as you know, perpendicular means that you got two lines that intersect at a 90-degree angle. So when we have perpendicular lines, they're intersecting to create a right angle. And that's always true of perpendicular lines. That'll always be true. So we're looking right now at perpendicular bisector. Nobody wants to see my hair. So perpendicular bisector is exactly what it means. Perpendicular meaning 90-degree angle. Bisector meaning cut in half. So a perpendicular bisector is a segment line or ray that cuts something in half at a 90-degree angle. And if it's cutting it in half, where is it hitting? What's the exact halfway point of a segment? The midpoint. So a perpendicular bisector will go through the midpoint. Okay? So we're going to start classifying some of these. We talk about, the first one we talked about was midsegment. Midsegment has to do with midpoint. Perpendicular bisector also has to do with midpoint. It's midpoint at 90 degrees. So there's going to be several of these special segments that deal with midpoints, several of them that deal with 90 degrees. So let's look at this one. In the diagram, ray EF is a perpendicular bisector of triangle ABC. Notice it says triangle, and it says that because it's not telling you exactly which side it's the perpendicular bisector of. Perpendicular bisectors are going to bisect a side. Angle bisectors are going to bisect an angle. That's the one we just talked about. Perpendicular, going to bisect a side. Got it at its midpoint. So it says in the diagram, if EF is a perpendicular bisector, not the, because there are going to be more than one of each of these in every triangle. Aha, we haven't gotten to that yet. So complete the following. What is the measure of angle CEF? Well, if this is a perpendicular bisector, what angle is it creating? 90 degrees. So CEF is a 90-degree angle, as well as AEF. This being a perpendicular bisector, that means it's cutting this side in half at 90. Perpendicular, 90, 90, okay? So what's the length, or what is segment AE congruent to? Well, if it's a perpendicular bisector, what did I say that meant? What's that word there, that magic word? Midpoint. That means that this segment AE, is congruent to this segment CE. Those two are congruent. It is a perpendicular bisector. It cuts in half at 90. It cuts in half at a 90-degree angle. So let's look at this one. Label the figure so that AE equals 8x plus 6. So I'm going to label AE 8x plus 6. And CE is 6x plus 18. Solve for x. Well, because this is a perpendicular bisector, bisect means that that is a midpoint. So that means that AE and CE are congruent, so I'm going to set up the equation as such. So I know that 8x plus 6 has to equal 6x plus 18. They're equal. It's a midpoint. It's a perpendicular bisector cut in half. You're going to get tired of hearing that. That's okay. I don't mind. So now I'm going to solve for x. So my first step is going to be to move the x's over. So I've got minus 6x. So I've got 2x plus 6 equals 18. And so my next step is going to move that pesky old 6 over. I don't really know if it's old. I called it old. I probably just insulted it. And my pen is running away again. I'm going to move the 6, subtract 6. I'm going to come up here. That leaves me with 2x equals 12. And then for the magic last step, divide both sides by 2. So x equals 6. And that is my answer. How can I check my answer? I can take my two sides And I can plug that 6 in and see if I get two numbers that are identical. I should, because it's in the middle. So let's do 8 times 6 plus 6. I've plugged in the 6 for the x, if you can see that. So 8 times 6 is 48, plus 6 is 54. So that means that I should get 54 for this one. So I'm going to do 6 times 6 plus 18. Again, I'm plugging in for 6 here. So 36 plus 18 is 54. Boom, we got it right. We rule. So 54 equals 54, which means we did it right because these two are equal. If I came out with two different numbers here, that means I've done something wrong. Because the whole premise was that they're equal to each other, because that's a perpendicular bisector. You're going to have nightmares about that. And that's a midpoint. Okay? So let's look at number 8. Let's go ahead and move down to number 8. And we're checking out number 8. It says FG is the perpendicular, which means 90 degree, bisector cut in half of triangle XYZ. So immediately, since I know this is a perpendicular bisector, I'm going to make my 90 degree angles, and I'm going to mark my two congruent pieces because now I know W is a midpoint. That's what a perpendicular bisector does. It goes through a midpoint. So complete the following. What's the measure of FWX? FWX, that's this angle. You guessed it, 90 degrees. You win absolutely nothing except for my praise. And what's the measure of FWZ? That's this guy. Really, 90 degrees. You guys are so smart. You're correct, 90 degrees. So what is ZW congruent to? Well, ZW would be congruent to XW because that's the midpoint. So let's look at the next example. It says, if the measure of angle FWX is 10x minus 5, find x. The first thing everybody wants to do is say, wait a minute, there's nothing to set it equal to. I don't know what that one is. You don't have to. It's a perpendicular bisector. What do we already know this angle measures? 90, right? So I know that 10x minus 5 has to come out to 90 degrees, right? Wow. Pretty smooth, right? So I'm going to solve this, and I'm going to add 5 to both sides. So 10x equals 95. Okay, 10x equals 95. And then I'm going to divide both sides by 10. So x is going to equal 9.5. It is okay in math world to get a decimal answer. I know that upsets some of you, but decimals do exist. So it is 9.5. That is the correct answer. Okay? And then the last example here, it says that DE is a perpendicular, what does that mean? 90 degrees, bisector, cut in half of triangle ABC. So it's a perpendicular bisector, so I'm going to establish, I'll speak English here, my right angles, and then I've got my midpoint established. So what I'm going to do next is I'm going to label the figure so that CE is 3x plus 10. That's this one right here. CE is 3x plus 10, and CA is 10x plus 8. Oh man, they're getting pretty tricky, aren't they? Well, what do you know about CE compared to CA? I'll tell you a secret. CE is 1/2 of CA. Remember, this is a perpendicular bisector, so that's a midpoint, which means this segment and this segment are congruent. So I know that 10x plus 8, which is the entire side, is going to be double the 3x plus 10. And then I solve. So I'm going to, I have 10x plus 8 equals, I'm going to distribute. 2 times 3x is 6x. 2 times 10 is 20. And then I'm going to move the 6x. So 4x plus 8 equals 20. Then I need to move the 8. This is so much fun. I'm going to subtract the 8 So 4x equals 12. And then I've got one more step. One más. So divide by 4. So x equals 3. And that's all you need because that's all you're doing is solving for x. Now, if I were to ask you to solve for CA or CE, you would have just plugged the x back in to get the answer. And let's check. Let's make sure we got it right, because if I got the right answer, what should happen when I plug x into CE and x into CA? CA should be twice as big, right? So CE is 3x plus 10, so let's plug in 3 for x. 3 times 3 plus 10, that's 19. Let's plug it into CA. 10 times 3 plus 8 is 38. And 19 times 2 is 38, so we are correct. And that is how you apply perpendicular bisector.